drawing with replacement versus drawing without replacement. If we have 3 identical balls in a container and we pick one ball at random without replacing it, the sample space is affected. So we can use the probability tree diagram to illustrate the situation. When we have the first 3 balls in the container, the probability is 1/3 because they are all equally likely to occur. The probability of picking any of them is 1/3. Now, after picking the first ball, we are left with 2 balls. So the probability of picking each of the balls again is 1/2. So you can realize that if, for instance, we are interested in picking a yellow and a white ball, probability of getting a yellow and a white ball when 2 balls are drawn is going to be this plus this. So the first one is 1/3 and the second is 1/2. So that gives us each of them to be 1/6 each over here. So when we are interested in getting the probability of picking a yellow and a white ball, then we are going to get 2 of them, which is 1/6 plus 1/6, and that is going to give us 2/6, which is equal to 1/3. So we could also do that without using the probability tree diagram, but we will see that in examples from WASSCE questions. So this is our first example. A bag contains 4 blue and 8 red identical balls. If 2 balls are picked at random with replacement, what is the probability of picking 2 balls of different colors? So this one is with replacement, so the sample space is not affected. So you have the total number of balls to be equal to 12. So probability of picking a blue ball is equal to 4/12, and the probability of picking a red ball is equal to 8/12. Now we're asked to calculate that 2 balls are picked and they are of different colors. So probability of 2 balls that are of different colors will be equal to, so different colors mean either the first one, so either the first ball is blue, or either the first ball is blue and the second one is red, sorry, not white. Either the first ball is blue and the second one is red, or the first one is red, and the second one is blue, and the second is blue. So the probability of blue is 4/12, and the probability of red is 8/12, plus probability of red being 8/12 times probability of blue 4/12. So this gives us 1/3 times 2/3 plus 2/3 times 1/3. So we get 2/9 plus 2/9, and this will simplify to 4/9. So the correct answer is D. Now we have this one. The table shows the distribution of balls in a bag. If two balls are selected at random with replacement, find find the probability of selecting either two new green balls or two old blue balls. So we have this and we are finding the probability. So we know the probability of new green ball is equal to 8 over the total number of balls, which is 20. Then probability of old blue ball is equal to 6 over total number, which is 20. So now we are asked to find the probability of two new green balls or two old blue balls. So we find each of them and add them together. So probability of two new green balls is equal to, the first one is two new green, or the second one is two new green, which will give us 8 over 12 times 8 over 12. Sorry, it's rather 8 over, supposed to be 8 over 20. So 8 over 20 times 8 over 20. So this gives us 2 over 5 times 2 over 5. Now the second one, probability of two old blue balls is 6 over 20 times 6 over 20, and this simplifies to 3 over 10 times 3 over 10. So this gives us 9 over 100. So this is supposed to simplify to 4 over 25. Now probability of two new green balls or two old blue balls, let me abbreviate them, will be equal to 4 over 25 plus 9 over 100. And this gives us the LCM of 100. Then 16 plus 9. So this total to 25 over 100. And this is equal to 1 over 4. So let's look at another example again. So let's proceed. The probabilities that James and Juliet will pass an examination are 3 over 4 and 3 over 5 respectively. Find the probability that both will fail the examination. So probability that James passes the exam is 3 over 4. So the complement, which is probability that James fails, is 1 minus 3 over 4, and that is equal to 1 over 4. Then probability that Juliet passes the exam is equal to 3 over 5. So the complement, which is probability that Juliet fails the exam, is equal to 1 minus 3 over 5, and that is equal to 2 over 5. So probability that both fails will be equal to probability that James fails and Juliet also fails, So this will be equal to probability that James fails times, so n means times, times probability that Juliet also fails. And we know these ones already, so we just substitute them over there. So that will give us 1/4 times 2/5, and this is equal to 1/10. We have this one. If u is equal to x such that x is an integer and it is greater than 1 but less than or equal to 20, then the first event is a multiple of 3 and the second event is a multiple of 4. And we have an integer picked from random from u. Find the probability that is not in E2. Now let's list the elements of the universal set. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So that is the universal set, and the first event is the multiples of 3. So we have 3, 6, 12, then 15, then 18. So these are the multiples of 12, multiples of 3. Then we have the multiples of 4 also. We have 4, 1, 4, 4, 2, 8, 4, 3, 12, 4, 4, 16. So the complement of E2 are elements that are in the universal set that are not in E2. So we have 1, 2, 3, 5, 6, 7, 9, then we have 10, 11, then 13, then we have 14, then we have 15, we have 17, we have 18, then we have 19. Since we left out something in the E2 complement, it is 20 inclusive, so 20 is also here. So that's it. Now these elements are 1, 2, 3 up to 15. So the probability of E2 complement is equal to 15 over 20, and that is equal to 3/4. So the correct answer is A.